All right, so thanks everybody for coming. My name's Jason. I work at Tapjoy right now, and I'm talking about getting the most out of your UI tests. So I think on the page it said getting the most out of your Selenium tests, and I'm going to talk a lot about Selenium. But the primary reason that I used UI tests in this instead of Selenium is because a lot of the things I'm talking about are principles that you can apply to any UI. So if you're not doing web browser testing or you're doing mobile testing, a lot of what I'm talking about is going to directly apply to what you're doing. So for starters, I want to talk about the testing pyramid. Who's familiar with this idea? A couple of you. Great. So the testing pyramid is the idea, sort of like the food pyramid, that there's certain kinds of tests you should have more of and other kinds of tests you should have less of. And the traditional way that the testing pyramid is formulated is unit tests on the bottom, integration tests as the middle layer, and UI tests as kind of the capstone. So here you have a lot of unit tests, you have some integration tests, and you have a few UI tests. So what do I mean by these layers? Well, a unit test is a logic test. It just tests your code in isolation, so you're testing your classes, testing your methods to make sure that they return correctly, and checking for bugs that way. These tests are really great if you want to refactor. They're really great for validating that your code was written properly, and sometimes they're used as a design tool if you're doing TDD. Integration tests are the next level. Those kind of check that different parts of your system talk to each other properly. So for example, if you have an API that's presented, you might write an integration test against that API just to make sure that it accepts the arguments that it says it does, that it returns the type that it says it does, and so on. You also might use integration tests to try to break things. What happens if I pass an int where I should have passed a string? What does the API do? What's it supposed to do? And you can write your test that way. And then at the top is a UI test. So what's a UI test? My definition of a UI test might be a little bit different than what you're used to. Oops. My definition of a UI test is a test that acts like a user. So if you think about the term UI, literally, it just means user interface. So a UI test is anything that exercises the interface that a user would have and behaves like a user to make sure that a user can use your application. So you might see this in a browser, you might see this on the desktop, or in a mobile app. All of those are valid places for UI testing. So why do we have UI tests at all? Are unit tests and integration tests good enough? Some people would argue yes, they are. But I don't think so. I think that UI tests have a particular need and place. Okay, we're done freaking out. So there are some advantages and disadvantages to UI tests. One advantage is it tests the entire system under test at once. So when you log into a web app via the user login page, you're testing the Apache configuration. You're testing Memcache. You're testing the framework you're using, like Rails or Django. You're testing all of the possible configurations. You're testing access to the database. All of those things are being tested in one test, and you can't do that with a unit test or an integration test. So there's a big advantage there to having a UI test. Second advantage is it copies exact user input. So if you want to know if a user goes to a page and does this exact thing, does the application work, a UI test is the only way to validate that, because it's the only way that you can mimic an exact user input. Thirdly, it focuses on proper function and output. So a lot of times tests get bogged down in things like, oh, I have to have a mock here, or we have to make sure that fixtures have been loaded, or all of those things. And UI tests kind of do away with that by just focusing on what happens when a user does a thing. Is this the proper function? Is this the proper output? And then finally, these are performance-dependent tests. So what's great about that is if your app is not performing well, the test will fail. And that gives you a nice warning that, hey, I did something wrong. Our performance is degraded. We should tell the developers. So what are the disadvantages to UI tests? Well, the disadvantages is that they exercise the whole system under test, they copy exact user input, they focus on proper function and output, and they're performance dependent. What? So just like Jimmy Fallon on The Tonight Show, I want to have some pros and cons. So what's the pro of exercising the whole system under test? You can detect subtle errors due to user input or system interaction. It's literally impossible to write an integration test that will detect a system running out of disk space due to a user doing something unexpected on a website. And even if you could write a test that would mimic that behavior, it's not going to be meaningful or be reproducible in other environments. You can write a functional UI test to do that. The bad side is it doesn't really tell you anything about the fail. It just tells you, hey, I can make this thing happen. And that's great, but then you have a whole lot of work to do to track down what system failed, where did it fail, why did it fail, what's the exact thing that caused the failure in that system. That's very different than the seemingly initial cause, which is your test. What about copying exact user input? Well, the pro is it's the user's exact behavior in the actual system with the actual output that a user sees. So what this means to a stakeholder, if my test passes, a user can do this thing, right? So just imagine the value that's given to Amazon.com by an end-to-end test that takes something, puts it in a cart, pays for it, and checks out, right? That tells Amazon, hey, users can actually buy stuff. And that's what Amazon exists to do. The con is if the UI changes, even in a small way, your tests are going to fail, even if the feature works. So for Amazon, again, they have a different problem. They A/B test all the time, and they A/B test tons of different UIs, which means that if they want to have an end-to-end workflow that checks out, they have to be able to handle every different UI and every permutation that the designers put together. And that can be really challenging, especially if the communication lines between the QA team and the developers aren't really strong. So a good example of this would be at my last job, we had a redesign, a V2 redesign, and all our tests broke when the design launched, even though we had agreed that we were going to keep things, the IDs on everything the same. And the reason was the IDs were all the same, they were just prepended by V2. So we had to do a find and replace in our entire system for our IDs and our test framework and put V2 in front of them. And that was just a miscommunication, but it cost us like a day of work. So what about focusing on proper function and output? Why is this good? It's good because when the test passes, you know the whole system works. You know, top to bottom, everything did the part it's supposed to do. What's the con? Well, you're not testing for side effects. Remember when I talked about the disk filling up? There's no way to check for that with a functional test. You're kind of limited in the browser. Now, you can write tests that check more than just the browser. Those actually kind of fall down into integration tests in some ways. You're doing something in the browser, then you're checking the database, then you're checking the disk, then you're checking some other store. That's a great test, but it's not really a UI test. And those can be really valuable, but generally they're more work than they're worth. What about performance dependence? Well, like I said, it gives early warning about performance degradation and user experience problems. The downside is it's HTTP bound, usually it's HTTP, sometimes it's something else, but you are going to go as slow as the user. So it's slow. It's really slow. It's ridiculously slow. What do I mean? Well, I mean that your tests are going to take multiple minutes to run, and sometimes you don't have time for that. So, in short, there is a huge potential for these tests to be good. There's also a very high likelihood that they're going to be misused. Or, to put it another way, with great power comes great responsibility. So, let's take a quick look then at the tooling landscape. When I talk about a technology, I'm going to try to get an idea of what you guys are using. So if you could give me show of hands whenever I'll kind of poll on what technologies. So who's using Selenium or WebDriver? Great, awesome. Selenium is sort of the browser automation framework of choice. I'm very quick to tell people, Selenium is not a testing framework. It's a browser automation tool. It doesn't have a concept of a test case, nor would they ever build one. So the number one question the Selenium project gets is, why can't you check HTTP status codes with Selenium? And the answer is, it's not a testing framework. There's no reason for you to be able to check that because a user automating the browser generally wouldn't know what the specific status code is. They only know whatever the page that's displayed to them is. And sometimes that page happens to say what the status code is. Sometimes it says, oh, we screwed up. Well, we screwed up could mean 500, 503, 404. You don't know. Moreover, it's not clear which status code they want you to show. For example, when you load a page, you're actually getting lots and lots of 200s. Because every time you fetch an image, it's a 200. Every time you fetch an asset, it's a 200. So let's say that one of them 404s, and then you ask for the status code. What should it give you, 200 or 404? Well, that's the kind of problem that can't be solved by using this. So that's not what this tool's for. It's a browser automation framework very specifically. So perfect for UI testing. There's also a bunch of headless browsers. Who's using a headless browser in some capacity? Yeah, probably Phantom JS. Yeah. Phantom. HTML unit. Yeah, it's always those. I had Ghost.py on here originally, and then I took it out. Headless browsers are great because they kind of let you do the same thing that Selenium does, but you don't actually have to start a browser. So you can run these in CI, and you don't need to set up some kind of frame buffer and set up a browser that can run or set up a slave that has a browser, and that's great. The downside to these is they implement some JavaScript. Some, maybe not all. They certainly don't implement a lot of the CSS display parts of JavaScript. So if you have a website that's dependent on elements being displayed and then not displayed, and you're using Selenium to check for that, and you use a headless browser, that's not going to work, or it will spottily work. There's a lot of these headless browsers that have been around for a while. For example, Titus Brown, who teaches at Michigan State, wrote a headless browser called Twill. And Twill doesn't support JavaScript at all. And when he was asked about this, he replied, no, actually it does support JavaScript. It supports the only totally supported subset of the JavaScript language that's supported by all browser vendors. That is none. So you'll see varying degrees of JavaScript support here. So that's the big knock against headless browsers. They are much faster than Selenium, though. And then various mobile tools. Who's using any of these mobile tools? Using Calabash? Appium a little bit? Great. So mobile tools are mentioned because this is kind of where functional UI testing is going. And it's important that we're able to test the interface of our mobile applications. And if we can't do that, then we're going to lose a lot of the benefit we just talked about from UI testing. These all have special challenges. I'm not going to talk a ton about these. If you are interested in mobile testing and it's something your company needs to do, I highly recommend you look at Appium. But the other tools have their place as well. And then there's these other tools. Who's using any of these? What are you guys using? QTP? Yep. Yeah? Okay. I'm going to knock on Sakula pretty hard. I apologize for that ahead of time. So why would I choose to talk about Selenium out of all of these tools, right? I started out talking about UI testing. Now all of a sudden, Selenium. Why are you going to talk about Selenium? There's tons of tools. And I even just told you that the mobile tools are probably where it's all going. Why Selenium? Well, there's a really good reason, and that is Selenium is slowly going away from the implementation and becoming a standard. Selenium 3, which is kind of on the horizon, actually isn't going to have a standard implementation. It's just going to be a spec. It's just going to say, this is Selenium. It's this set of commands. And the browser vendors are going to implement it. And then third parties like Appium are going to implement it. And that's going to be how we're going to automate UIs. So this has already happened. Chrome driver ships separately from Selenium. You have to go get it from Google. Firefox driver is included in Firefox. It's built in. That's the future. Even Microsoft is taking ownership of Internet Explorer drivers. So we're seeing a lot more vendor-supported APIs and standards around browser automation. And that's important because that API that's being defined isn't specific to the web on desktop. It's a general UI automation. So if you think about UIs, they're really just trees, right? You tap on this, you touch or you click on an element and something changes. And that change is a decision tree. And so you can envision a DOM or a mobile application UI the same way. They're a tree. And Selenium is defining an API for walking that tree in some meaningful way. So both Appium and Phantom.js already have support for the Selenium protocol. Calabash has support for the Selenium protocol via plugin. You could automate Windows 8 using Selenium with Rainbow Driver. So this is a broadly adopted, mature spec. And I think it's kind of the future of automation. It's the present of automation, but it's also the future of automation. All right, so big warning, browser automation ahead. If you aren't really interested in the browser, try to listen to the principles. But I think everybody here is kind of into browser automation in some capacity. So, all right, so the first big question that every person has to deal with when they are looking to start automation. Really quick, show of hands. Who's at an early stage in automation at their company? Okay. Who's at a mature stage of automation at their company where you'd say you have a big suite of tests or you've already built everything? Yeah. Who has no automation at their company? All right, good. So when you're asking yourself what tests you should have automated, these are the tests that I put into place. The first question is this a critical or profit-generating functionality? Is this something that if it broke tomorrow, somebody would care? And why would they care? Would they care because it's what our users really care about, or it's how we make money? If so, then that's a good candidate for automation. It's also a good candidate if it kind of relies on real inputs from the user. If you can fake inputs to test it, then it's probably not a good candidate for a UI test. You should probably just fake the inputs. Usually, UI tests are automating some sort of end-to-end workflow. Like I gave the example of Amazon with a cart. Usually, it's a funnel because the web is commerce-driven. So we're almost always automating in the funnel. Sometimes we're automating user sign-up flows, which are also a funnel. Sometimes you're automating some sort of create, read, update, delete through a UI, which is an end-to-end workflow. I don't think this is a requirement, but it's generally a good sign that a UI test is a good choice. It's critical, in my opinion. I'm probably breaking from some established dogma here, but it's critical, in my opinion, that you don't use UI tests for data or permutation-driven testing. What do I mean by this? I don't mean data-driven testing. It's fine if you have data files that drive your UI. But if you're looking at something and saying there's 36 combinations we need to run through the UI, you probably don't want to use a UI test for that. You probably want to use a UI test for one permutation and use unit tests for the other 35. And then you shouldn't be validating data with a UI test. You really shouldn't. Sometimes this is going to be forced on you because management's going to say you have to do it. But generally, if you have an application that pulls a bunch of data from an API and visualizes it, don't be using your UI test to validate that it did the math right in a table. That's a really bad tool for that job. There's much better ones, specifically JavaScript unit tests, because you're probably manipulating the data in JavaScript. So test it there. And then the last thing is ask the question, should this be manual? Is this really something that we can automate reliably? Is this something where the automation gives us a real benefit, or are we going to have to have human interpretation of this anyway? Oftentimes, your most complicated, your most critical, your most important tests have to be done by a person. Really, nothing should ever ship without having human eyes on it. Now, whether or not those human eyes have to be a dedicated QA person who's a manual tester, I'm not saying that. But I am saying that if at some point in your development cycle, there isn't a developer or a QA person or a project manager who's actually laying eyes on your product, and not even the whole thing, you're doing it wrong. Question?
Yeah, can you explain a little bit more about point 4, because it says if you are testing different permutations and it's better to do one using this browser tool and the rest with the unit testing.
Mm-hmm.
So if I want to perform this end-to-end testing with different profiles or combinations, can we really do it with unit testing? Because unit testing, we do not have access to all the applications. End-to-end testing is not possible with unit
Right.
testing.
So let me give you a simple example of what I mean. I actually have a demo I'm going to do here in a minute that demonstrates half of it. So let's say that you have a cart-based workflow. Let's say you're selling cable, okay? And people enter your workflow and they select a cable plan. And then based on whether or not that cable plan includes HD, they're taken to one page. And if it doesn't have HD TV, they go to a different page. That's two different things that you need to check. And you have 30 plans that are displayed. You don't need to have 60 tests. You should have 2 tests. You should have one that goes down the HD path and one that goes down the non-HD path, because those are separate pieces of functionality. Then what you should do is once you've exercised that functionality, you should have a unit test on the piece of code in your backend that says, should they go to the unit HD page or the non-HD page? So that way you're validating it at 2 different levels. You're saying at the unit level, this piece of code does return HD or non-HD correctly. And then at the functional level, returning HD or non-HD correctly actually does what we think it does. And so that way, because I've seen a lot of cases where people would have 60 tests. And that's an extreme example, and it's very simplified to demonstrate my point. Where it's challenging is when you start to get into things where this functionality is very subtly different, and you have to start saying, okay, that's a piece of library code. We don't even control that. I'm not going to run 60 tests to validate it. I'm going to test at the boundaries. I'm going to validate interactions, and I'm not going to worry about, okay, well, this one's spelled differently than that one, so I have to test them both. Did that answer your question? Okay, so let me show you the other half of that. Quick demo. So I have nothing to do with this application. I've never seen it before. But I was looking for something that would allow me to demonstrate what I mean about permutation testing, and this date picker is a really good example. So if you look right in the center of the screen, this is a simple date widget. You've probably got something like this on a site somewhere in your system. It lets you pick a date by year, month, and day of the month, and pick a time by hour and minute. So it's very tempting to look at this and say, whoa, wow, this is going to take a ton of test cases to cover all the functionality of this. Wrong. Take very few test cases. I could list about 100 test cases for this. There's no need to automate them in the UI. So let me give you a simple example of what I'm talking about. This is supposed to change the theme. Obviously, testing that the theme changed is a great thing to do. And you can do that via a UI test. That's fine. You don't have to check every theme. Being able to select a year, a month, and a day, very valuable. You should probably have a UI test that checks that. You don't need to have a UI test that checks every month, every year, and every day. However, there are some good edge cases to test in here with UI tests nonetheless. For example, can it display a month with 31 days, 30 days, and 28 days? That would be a valuable test to have. What about leap years? That would probably be a valuable test to have as well. However, once you've validated the basic cases like that, any other cases can be JavaScript tests, which run very fast, and they will be able to test anything else that you're worried about. So if you really do need, for some reason, there's a requirement that you do permutation testing and make sure that everything will display, JavaScript tests. Same goes with time. In the UI side, now let's pretend for a second that this widget actually returns some value into your website. That's where this JavaScript testing becomes valuable, right? What happens if you select an AM time? What happens if you select a PM time? You're going to want to make sure that AM and PM both appear, but you don't want to do that via a UI test. You want to do that via a JavaScript test. What you're doing with the UI test is just making sure, yeah, I can select these little bubbles, and they stay selected, and all those kinds of things, right? So I hope that makes sense as kind of an example of where I'm going with this. Don't do permutation testing. So how do you automate? This is a really simplified example. It's in Python of what a test might look like. if you were starting to write a Selenium test. So we get a web browser, in this case it's Firefox. We go to a website. We find an element. That's one of the core concepts of Selenium, is finding and manipulating elements. We find two elements, in fact, login and password. And then we send the keys. There's a typo. That second one should say password.sendKeys. And then we submit it. So why is this troublesome? What's wrong with this? Well, if this is the only test you have, nothing. This is a great test if it's the only one you have. The problem is when you make a second one. When you make the second one, you duplicate a lot of code, right? So this whole block in the middle where we're actually logging in is now in 2 places. And if we had 50 tests, it would be in 50 places. And obviously this is bad. So how do we fix it? Well, we refactor it. So we create a class, and we stick the login stuff into the class. This typo has persisted the whole way through, by the way. And then we call that class in our actual test. So here, I've taken the login, made it a method on login page. And on the right side, I import login page. I create it by passing it a WebDriver instance. And then I just call login with username and password. And it works. And it makes my tests more maintainable, right? Because I would do this across everything. I would have a navigation object that had all my navigation that I could call. And this is really probably pretty basic stuff. And yet this is where almost all of the problems happen when people automate, because they don't put the really redundant things into page objects. They do them over and over again in different ways in different places in their code. So with that, I want to kind of transition into what I'm calling the 7 deadly sins of Selenium, which,
Can I ask a
yeah,
question?
yeah,
So page object model, is there a situation where that would not be the best model?
sure.
Framework?
I'm not using it right now. The system that we have right now is oriented around some business concepts. So if you can imagine having an ad platform, right? You have ads that run. You have publishers that publish the ads. These are all objects in your system. And you're going to want to be able to create and interact with those objects. So another way to do this is to kind of define them as business objects and create and interact with those and hide the logic that way. The point isn't so much, is it a page or is it some other kind of object? The point is, do I abstract my logic to kind of one place and one place only? And with Selenium, that means hide it. Just hide it all in classes and do your best to keep them all to one. The downside to doing the page object model and the business model is people tend to have terrible inheritance trees as they try to make everything go only to one place. So it's important that the people who are designing these things have a very good grasp on what composition is and how to compose classes instead of just creating inheritance, because the knee-jerk reaction is just to keep going up levels. Right. And so you have, login page, which inherits from base page, which inherits from company page, which inherits from, page, which inherits from page object. And you're like, okay, well, where did this method come from? I have no idea. I wish I could tell you. And the same thing will happen with test classes, So it's important that you compose and make your code reusable via mixing it in or just straight composition, something, anything besides deep inheritance. All right, any other questions about page objects while I'm here? Is everybody relatively familiar with page objects and how they work and why? I'm going to talk more about them, so if you're not, tell me now so that I can focus on it later. Okay, great. I'll talk more about those. So, 7 deadly sins of Selenium. Let's get going. All right. So the first is, first thing before I start, buyer beware. That's what caveat emptor means. Buyer beware. Don't just blindly listen to me and go to your company and be like, this guy said we have to do this stuff, so gosh darn it, we're going to throw everything out and change it. Hopefully this is helpful to you, and hopefully it gives you a new way to think about things, and hopefully I'm pushing some buttons, and you're like, well, we do that. Okay, well, should you be doing it? Well, yeah, we should be doing it. Okay, cool, do it. It's great. But I think that I have pretty good reasons for saying what I'm saying. First things first, don't use a record and playback tool. If you are, stop. So what I'm saying here is generally don't use a record and playback tool. So this is something like Selenium IDE, which if you're still using Selenium IDE, I feel so bad for you. That thing is so old, it's barely supported. You should be using a tool called Selenium Builder, which I gave a talk about at Selenium Conf last year. So if you're interested in it, go look up the Boston Selenium Conf talks. I talked about Selenium Builder. It's much better, and it exports WebDriver code instead of Selenium RC code. And it actually exports code that can run. Like you could actually build and maintain a test suite that way if you had to. Some exceptions to this. If it's a one-off or it's a throwaway, go ahead. If your project managers are using record and playback tools, great. Sometimes, but not usually, it's worth it to use this to export scripts to fix up. Generally, this is if you have a page that's never going to change. If you're like, man, we've had our login page for 6 years and it's just not going to change, and you want to automate it using a record and playback tool, go for it. Usually the cases that a record and playback tool are good for are so simple that you might as well just script them by hand. That's kind of the problem. And then if you have somebody you need to sell on automation and they're like, do a proof of concept, use a record and playback tool. You can get it done like that, and you can go to them and say, like, here's the power of it. Boom, watch the browser go. Odds are really small that you can write enough scripts to do a really impressive demo in like 2 days. Or if you can, they're not going to be convertible into a product anyway. You're going to have to throw them away and start over. And if you have to throw them away and start over, make your life easy and use a record and playback tool. Why don't use a record and playback tool? Well, one thing is it produces brittle, badly factored code. The selectors it uses are terrible. Those are going to get you into so much trouble. And it has no concept of timing. So if your tests are timing dependent in any way, this is going to break right away. And then it's almost always limited to being run in a local browser. Like Selenium Builder, you can run them on Sauce Labs. But maybe you don't have a subscription to Sauce Labs, and you want to run them in your local Selenium grid. Converting them to run in your Selenium grid is a time-consuming process. You can do it. But at that point, you're investing so much time into this, why don't you just write them from scratch? Second, not reusing code. So, how many of you would say that your test automation consists of a collection of scripts? Okay, what do I mean by that? I mean, do you have a bunch of files called test something, and when you open them up, they're just a list of instructions that are basically run by your test runner, top to bottom? Like it's a Selenium script. It doesn't import from anywhere else. There's no library code. It's just Selenium instructions the whole way down. If so, you're not reusing any of your code, and that's a big problem. Because whenever something changes, you have to go find it in every single one of those files and fix it. How many of you would say that your tests are well factored in terms of reusing code? So like how many of you have good library code that you've built out for your tests? A couple of you. What do I mean by that? My rule of thumb is the second time I do something, I figure out how to refactor it. So at my last job, I was automating an application that was built in Django. And in Django, a lot of things kind of look the same. The nav bar at the top was the same on every single page. So when I wanted to navigate from one page to another, the first thing I had to do was find the navigation bar, then find the link inside that I wanted and click on it. So I would have had find navigation bar in my tests like 75 times because I navigated a lot. So instead, I created a navigation class. I put the logic to find the bar in that class. And then I added methods for every page I could navigate to. Why was this beneficial? Well, it made my test more maintainable and more reliable because I could handle the one button that didn't work the way every other button did inside a class where it was encapsulated, and I didn't have to worry about that leaking out into my API somehow. But it also was good because when we added new pages, supporting them was as easy as adding a method on the class that had the logic contained in it. And that navigation element was mixed into every page class across the entire application. So there was a consistent interface. It was very easy for new people to learn, and to come on and write tests. So that's the example of code reuse, why we do it. Why do we waste the time to write a page class and learn how to mix it in? Because it makes our lives easier and it makes our code more maintainable and more reliable. Another example of this, we used a library called Kendo UI. Is anybody familiar with that? Be very grateful. Kendo UI is a JavaScript library for widgets. So or at least that's what we used it for. It lets you put like a data grid on a page really easily, or it lets you make visualizations quickly. The problem with Kendo UI is that it's extremely JavaScript specific for what browser it's in. And it works in a way that no other widgets I've ever interacted with work. It puts a fake object on the page that you can't interact with, and then it detects when you try to interact with it and fires JavaScript elements under the hood. So whenever Selenium tries to interact with it, it throws an error because Selenium looks at it and says, hey, I can't interact with this element. So we had to fake it and just fire the JavaScript elements under the hood, which meant that every time we ran into a Kendo element anywhere in the page, we had to have all these blobs of execute script commands to make it do what we wanted. So instead what we did is we built a Kendo library, and we shoved all that JavaScript logic into that library. And all of those commands existed in statements that were in one place, that were tuned, that we made sure worked. They weren't just some random developer hacking JavaScript until it did what he wanted. And that's the benefit, again, of reusing your code and abstracting it to a common place. Another thing about reusing code, this is kind of code reuse, kind of not, but it does relate to this well-factored code. Load your server-side state with fixtures and load your client-side state with cookies. So what do I mean by this? If you need to test an application and that application needs to have 10 users set up in order to test it, and those users need to have varying permissions or attributes, don't use Selenium to put those in and set them up. Write a separate Selenium test suite to make sure that you can do those things, but don't set your fixtures up using Selenium. Write database fixtures and load them into your database before, get your test environment to the point where you can load database fixtures. You'd be amazed how few people seem to have this concept. It's really important. Or just, if you have a test environment that's persistent, just go add the users and just make them there as fixtures. The same thing with client-side state. Don't log in every time you run a test. If you have to log in, if your app is behind a login wall, you should log in once. The other 500 tests or however many tests you have should never log in. They should just have cookies set. So I actually have an example of how to do that here. If my site at mysite.com set a cookie when it loaded, this would get the cookies out, and then at some future time, I create a new WebDriver instance and I load the cookies in. And that's it. That's really all you have to do. You can serialize them to disk and then load them from disk later if you need to. They generally exist as, in this case, it's a Python. Cookie is a Python object that gets loaded. But if you're doing Ruby or Java, it's just going to be a native object in your language. I'm going to talk a little bit more about how to avoid dependencies in your tests when you do this, because that's always what people come at me with whenever I say this, is they're like, oh, but then your tests depend on each other. They can depend on each other if you do it poorly. But if you do it well, it doesn't have to. Question?
Yeah, that's exactly what my QA get back to me when I try to tell them to do these kind of things.
Yeah. I mean, it depends on your conception of a test. If you consider your fixture methods, like your setup methods, tests, then technically you technically have a test dependency. Right. But I'm also a proponent of fail fast, so I love that. I love the fact that being able to log in is a dependency for running the Selenium test suite. Because if I can't log in, I don't even want to run the rest of the tests.
Exactly. Yeah.
So for the server side, what I tell people is, look, test your create, read, update, delete operations, and for everything else, use fixtures. So if you need to set up 30 clients in order to run your test suite, set up one. Put the other 29 in via fixtures. Call the API directly. Write a tool that lets you just inject them directly into the API. Don't incur the overhead of HTTP and the browser constructing the DOM and JavaScript running just so you can test set up your fixtures. Like, save that for the things you actually need to test, and for the rest of the time, just set it up via fixtures. So the third thing people do, they run tests one at a time. I've never understood why people do this. Tests should be totally isolated with setup and teardown at the test level, the class level, the module level, and the test suite level. All right? So in Python, nose supports all of this. You can create a nose plugin to do suite level setup and teardown. You can do module level setup and teardown, it's built in. You can do class with setup class, built in. You can do test with setup and teardown, built in. And they support a sane model of overriding each other. So why would you do this? Because if you do this right, it allows every test to run completely isolated from any other test. So as an example with login, I would have login be a suite level fixture. So the test, before it even tried to run any of the tests in the suite, it would log in. And if that failed, it would just abort. It would hit the reset button right away because something is horribly wrong if he can't log in. If it does log in, it saves the cookie and sets it as a test suite level fixture. And so then every other test just accesses that cookie. And then we don't have to log in. So if you have 20 tests and your login takes 10 seconds, that's 3 minutes plus. That's over 3 minutes for your test suite that you just saved by using a cookie instead of logging in every time. That doesn't seem like a lot, but it's a lot. So really, this is the only way to get test isolation and to make tests run fast. Run them massively in parallel. If you're using a headless browser, run them 20 or 30 at a time. Get a big, beefy box in a data center for your CI machine that runs your functional tests, and just run them as wide as you can. And if that's not enough, sign up for something like Sauce Labs and run them as wide as you can. Thoughtbot, I don't know if anybody's familiar with Thoughtbot, but they said there's a 30 to 40% speed up right out of the box by going with parallel. You're limited by your longest test here. So if you have a 5-minute test, you're never going to get under 5 minutes. So we're going to talk more about that in a minute. You shouldn't have a 5-minute test. One of the things I mentioned is tests running quickly. I think it's horribly underestimated how important it is to have your functional tests run quickly. Really, your developers should be running your functional tests all the time. They should be ready to do a commit, and they should run the tests. Right? Not as often as their unit tests. Their unit tests they're running constantly, ideally. But before they commit, they should run your functional tests. And it should only take them about 3-4 minutes. And long enough for them to go get coffee, come back, see the green, be good. If your developers aren't into that, you should have a post-commit hook that's running in Jenkins that runs the functional tests after every commit. Well, if you have to roll up 15 commits and then run your functional tests because your tests take so long, then there's 15 times the exploration that has to happen on a build fail. But if you can run them after every single test because every single push because they only take 4 or 5 minutes, then you're going to get your developers buy-in on the value of the tests, and they're going to say, yeah, it's great. I get quick feedback. There's some more stuff that goes into that. You can't just have a test for everything. This is why I talk about don't run combinatoric tests. Don't run permutation-based tests, because you want your tests to be able to run in a reasonable amount of time. And your developers need to know that they can trust you not to be running tests that don't matter and don't give them a signal. Because ultimately, that's what this is all about. We want to give signal to them. Is this quality or not? Another thing that people do, they use a local browser. I don't even use a local browser for development of my Selenium tests. I run Selenium server on my machine, and I have my Selenium WebDriver set up to talk to the local Selenium server, which talks to my local browser. I don't use WebDriver.Firefox anywhere. I only use that for my example here. Why? Well, one, if you do that locally like that, you're tying yourself to one browser. And even if you have your test suite set up to use multiple browsers locally, you're tying yourself to a local implementation. That means that any kind of timing problems that are going to be happening by going over the wire are going to be multiplied in your tests. It means that it's really hard to scale because, like, how many instances of Firefox can you run on one machine before it just gives up? I think it's probably around 4, 2, right? Not many. The answer is not a lot. And when I worked at Sauce Labs, we ran 1, and only 1. And we kept getting requests from customers like, hey, put multiple browsers on a single VM so that we can run 10 at a time but only spin up one VM. It doesn't work that way. The browser gets really slow and it crashes. And then you get flaky tests. It also gives you a completely false experience and a false expectation of speed. I had one guy who was writing Selenium tests at my last job, and he used to complain that our build took so long. And he's like, man, the tests only take 3 minutes on my machine. Why do they take 30 on the CI box? And I was like, well, show me your setup. And he was running a local developer instance with a local browser. So the requests never went off his box, ever. They never went across the internet. So he was getting, 5 millisecond round trip times on his Selenium commands. In reality, you should expect a half second. That's about how long it's going to take on your CI machine to go to your browser, your app, and back. Maybe longer. So if your Selenium test has 100 commands and it's a half second per command, that's a 50-second test, minimum. That doesn't count loading, right? That's just Selenium overhead. And really, don't use a local browser because you should be running all these in CI anyway. And if you're using a local browser, you're not using CI. So local browsers are great for experimentation. If you don't know what you're doing, you're like, oh man, this Selenium feature, like cookies. I want to test loading cookies. Yeah, fire up a local browser. Do it for real. Use an interactive console. But if you are writing tests, don't write them with a local browser. Don't write long tests. Tests should be less than 30 seconds. I mean, really, ideally less than 30 seconds. If you're using my cookie trick and you're navigating directly to the URL you want to test, you'll save a ton of time. So let me give you an example. If your application has a user creation page that's at mysite.com/user/create, don't go to the login page, then the user page, then click create a user. Just go to the user creation page. You can have one test maybe that goes and checks that the button's there and that you can get through the path. That's good. But every subsequent test should just go directly to the user page. So what you might need to do is have some sort of suite level constant that gets initialized that says, yes, I've tested this. And those flags get checked, the suite behavior changes. That's kind of complex, but it can be done. The point is that these tests should test one thing or as close as possible to one thing. So one of the ways that I handled that same scenario, the user create, was I wrote a test that navigated to that user creation page and then passed. And then it launched my user creation tests at a separate time, and it went directly to that user page and bypassed the whole workflow to that page completely. And that was great for two reasons. One, it gave me the granularity of telling me, hey, I can't get to the page as the reason for failure versus I can't create a user as the reason for failure. And then the other reason it was great was because I needed to create 5 or 6 users during the course of my test with different properties and different ways, and it sped that up immensely. Another thing is you should have explicit assertions for what you are testing and no assertions for anything else. Please do not be the person who is writing tests where they are asserting the presence of a link before they click on it. If the link isn't there, let Selenium raise its element not found exception and then catch it and do something with that. Those exceptions are there for a reason, especially if you're using a language like Ruby or Python, which has this kind of idiom built into it where you should be asking forgiveness, not permission. Don't be asserting on the presence of elements. That's why these exceptions exist in the first place. And be aware, asserting the presence of an element is an RPC call for Selenium, which means you're incurring the penalty of the round trip time to actually make the call. And then the last thing is longer tests. It's just longer for something to go wrong. Honestly, the browser's not that stable. You have a 5-minute test, pretty good odds something's going to go wrong. You're going to have a drop packet or something's going to happen and your test is going to flake. So it's just not worth doing. And then lastly, fail fast. Always ask yourself, can I fail any faster? If this is broken, what's the fastest way I can fail? Because what you ultimately want is that signal that something's wrong. So like I said, if login's broken, fail your whole suite. Don't even waste your time running the test. Your developer shouldn't have to wait 30 minutes to find out login's broken. They should know right away.
So like an end-to-end type of test, I mean, you gave this Amazon example where you want the user to log into their Amazon, browse something, select an item, add it to the cart, and that might be less than 30 seconds, check out.
Yeah.
I don't know, but you could, I mean, hypothetically, an end-to-end test for some more complex applications could take longer.
Yes.
Is that so? would you recommend not automating that, or how would you?
Is it in your funnel? Right? Is this your core user experience? Are you automating something that a user is going to do directly?
Yeah.
My old boss, Jason Huggins, he wrote the first version of Selenium. He calls those tests the get out of the temple tests, like Indiana Jones, where he grabs the golden head and then has to run the whole way out of the temple, being chased by the boulder. The point is, if he fails anywhere, he's dead. So that was the most important part of that whole stretch. Well, what's your get out of the temple test? Right? For Amazon, it's people putting things in their cart, checking out, giving them a credit card information.
Right.
So I would recommend they test that whole thing end to end. But guess what? If they have 5 different carts, they should put something in their cart, cache the cookies that say this thing is in my cart, and then they should load the next version of the cart and throw the cached item in there. Right? Isolate down to the thing you're testing. What are you testing?
Right.
Are you testing putting things in the cart?
Right.
Then test that like 50 times and test your checkout once.
Right.
But yeah, that one end-to-end test is super important because that's the thing that you can point your stakeholders
Then
to.
just don't do that over and over again. Do
No.
that once and then.
Exactly. Yeah, and use cookies because ultimately cookies are the way we do this on the web anyway. So like Selenium isn't creating a new mechanism for loading data in the browser. It's just using what's already there. Another thing people do that's horrible, bad weights. Yeah, I know, I'm getting really kind of snarky. Okay, so fun fact, when I started my last job, there was a Selenium test sitting there, and I opened it up and looked, and there was a sleep 30 right in the middle of it. And I was like, what the heck, a sleep 30? And so I asked the guy who wrote the test, I'm like, why is this here? And he goes, well, it fixed the problems. And I was like, okay. And what was the problem? I don't know, but a sleep 30 fixed it. I'm like, well, did a sleep 29 work? He's like, I don't know, I didn't try that. And I was like, I see where this is going. If you're using explicit sleeping in your tests, obviously that's bad. But where people get tripped up is they don't realize Selenium has 2 built-in wait methods that you should be using. One of them is implicitly wait, and the other one is WebDriver wait. So these work 2 very different ways. Implicitly wait is a global timeout for any element searching or any polling operation. So for example, if you set implicit wait 30, it will wait up to 30 seconds before telling you an element does not exist on the page. Now, if you try to interact with an element that you had found previously, it will not wait 30 seconds for that command. So there's a misunderstanding about this. A lot of people think it puts a 30-second wait on every command. That's not true. It puts a 30-second wait on DOM interactions, direct, like searching the DOM kind of stuff. If you already have an element located, it'll either return a stale element exception or it'll work. There's some other exceptions it could raise. WebDriver wait is very specific. WebDriver wait has a parameter you have to pass called an expected condition. And an expected condition is like element is visible or element is not visible or a DOM state change of some kind. And what that does is it says poll every 500 milliseconds until this expected condition is true. And so it's a little bit more complex usage, but it gives you very fine-grained control over those weights. I found that sometimes these are fairly browser specific in whether or not they work, but if they're working, they're hands down the best way to do it. If neither of these work for you, write your own spin assertions. Just write a method that checks, sleeps for a half second, and then checks again. And checks for a certain amount of time and then gives up. And then you can raise a custom exception too, which is more information and makes it easier to read your tests anyway. So those are those are the good kind of weights. Very often, a failure caused by timing or a race condition is a sign that you've either architected your tests wrong or this isn't really a test you should be running through the UI. Sometimes it's just your developers are really bad and they wrote a terrible UI that doesn't work. But usually it's a problem with test architecture. I'd say most of the time it's a problem with test architecture. You haven't thought about what the next thing that's going to happen is after you execute a command. And that next thing doesn't block or wait in any way for the previous thing. So you need to introduce something there that's a WebDriver wait that will slow the test till the conditions are right for it to continue. The last thing people do is they just have too many freaking tests. Does your functional test take 6 hours? It shouldn't. Are you permutation testing? That's probably why it takes 6 hours. Are you seeing lots of flakes? A good measure of this, when you come in the morning and your tests ran in CI overnight, how long does it take you to interpret the results? I know people who it takes them all morning because they have 60 failures and 59 of them are flakes. Are you testing every single test in every browser that you claim to support? That's probably not necessary, honestly. Probably most of your site works in every browser the same way, and there's really only some edge cases that you need to test in every browser. My favorite, do you have an expected failure or a broken condition to keep the build green? So do you have a test that's been broken for like 9 months, so you set skip test on it? You might as well just delete it. Seriously, just delete it. Because nobody's paying attention to that test anyway. And so far, your company is still around. So that test really wasn't adding any value. I know people who basically have the rule, if your test fails for 24 hours, I delete it. Because nobody cares. And there's some good wisdom there. I'm not saying do that, but start thinking that way. If my test is failing, if my test fails in the woods and nobody hears it, did it really make a sound? Sorry, that was terrible. Another example of this is some people have a mechanism in their test suite where when a test fails, it runs it again to see if it's a flake. So if it fails once but passes the second time, then they say, oh, it's not really broken. I'm of two minds on that. On one hand, that's great because it keeps you from having to interpret the result. It shows up as a flake and you know that's a flake, and then you can do some metric collection later on to say, hey, this one test flakes like every other time we run the build, we should investigate it. On the other hand, something tells me that that's a pretty good sign that you need to learn how to write better tests so your application is messed up. So maybe as a stopgap measure, that's good, but that's not the kind of system I would build long term. All right. So what's my ideal world? Yes, I know, ideal world. It's great. I would love to see a small number of Selenium tests covering critical cases and UI-specific issues. Test your funnel. Test things the users demand. If you know, if you're Facebook and all your users are poking each other, test the poke. Make sure it works, because the last thing you want to do is have that break and have all your users be complaining, right? But if you have a feature nobody uses, that's probably not the most important thing to test. And maybe you'll have time down the road, but I'm pretty busy. I don't know about you. I don't really have time to automate things people don't care about. At the API level, I would have a medium number of contract tests that ensure that the API works as expected. So there's a lot of good resources to read about testing APIs. From a QA perspective, what we care about is, does the API present what it says it presents? And does it do the thing it says it does? So there's two steps to that. One is validating the API, which is to say, hey, you said that you return an int, do you return an int? The other half is validating what the UI claims to do, which usually involves going into the database or going into the application and validating that whatever change was claimed happened. So if you hit the API and you hit it with delete, does it actually delete the record? Is it supposed to delete the record? Maybe it's just supposed to remove access to the record. Okay, that's easy enough to test. And then unit tests. Back-end unit tests for the server side are really important. And JavaScript tests for the front end are really important. The JavaScript unit tests really should be replacing a large portion of your UI tests. Quick word about CI before I finish. That was an empty slide. Look, nobody wants to wait on the build. Nobody wants to wait on the build. They want to push their code. They want to see it get integrated. They want to know it's going to ship. So what can you do to make sure nobody wants to wait on the build? Well, you can split your tests up, right? Does every test need to run on every push? Maybe, maybe not. Probably not. What has to run right now? That's what you should figure out. And then tag your tests. Look, if you're using a framework, it probably has a test collection and tagging mechanism. If it doesn't, you should build one and make all the other people using your test framework really happy. In Python, nose has a really great ability to tag a test and you're done. I know in RSpec, you can create collections of tests that can get run. this isn't a new concept. So you should have a subset of your tests that are really quick, easy to run, and validate most of the things correctly. So this is where that one end-to-end test becomes super helpful, right? Because you can tag it as your end-to-end test, you can run it, and then, okay, maybe you didn't test every permutation, but we have some pretty strong signal that we didn't break anything in the funnel. And so then we can start looking at those other things. Look, run your fast tests all the time. Like, I worked at one company that had a Jenkins build that ran them on every push, and then if there wasn't a push for 15 minutes, it ran them again just because. And why? Because they were fast, and they only took 2 minutes, and we could run them whenever we wanted. They also ran 100 at a time, so it was really easy. And then, again, always be asking the question, how can we fail faster? How can we give signal to the developers that something is wrong even faster? Usually this takes the form of some sort of dependency. If you think about it, most of what we're testing is a string of events that are linked together. And if the first link in the chain breaks, none of the rest of it's going to work anyway. So don't waste your time with the rest of it. Just fail at the beginning, right away. And fail meaningfully. Don't just say something went wrong, but fail with some message that gives them, the developer the ability to interpret what's happening. Lastly, look, Selenium infrastructure is a problem you really actually don't want to solve. A lot of people say they want to solve it, they don't. So just go to the cloud and be done with it. Use a headless browser and be done with it. Don't sit around playing with X virtual frame buffers and virtual machines unless you're in DevOps. Like, that's not what QA people are good at. It's not the way we think. If you're like me and you're writing automation tools, you want to write things that help developers make better code. And playing around with X virtual frame buffer doesn't do that. It just makes me angry. So yeah, to the cloud, headless browsers, they're your friends. Use those. So that's all I have. Thank you very much.